of 4.2. If you recall from the front side, we learned rules for how to find vertical asymptotes, horizontal asymptotes, and poles, yes?
Yep.
Okay, so we learned how to find them. We didn't really look at the graphs yet. We're going to look at graphs today. So when it asks us to graph each function, keep in mind, if you guys kind of remember, what are these graphs looking like for the most part? It's the two curves that are going out from each other, yes? And they're in opposite corners, okay, depending on what's going on here. So in order to graph these, they're going to look like that, okay? We just have to figure out exactly where, and they're sometimes shifted over a little bit and stuff. But we're going to start by identifying the asymptotes. We're also going to talk about how to find their intercepts, because that will help us to decide which way they go, so where they cross x and y axis. And then as necessary, we'll find some other points to help us along the way, okay? So let's start number 1 over here, or excuse me, part A. And my first step, I'm going to find my asymptotes. So let's start by finding vertical asymptotes. What do your brains remember from yesterday? Okay, denominator equal to 0. So 3x minus 4 equals 0.
Yeah.
What happens? If it's 3x minus 4, we're going to add 4 over, and then you're going to divide by 3, and x is 4/3.
Yeah.
That is my vertical asymptote. It's not great, but it is what it is. Okay, it's a fraction, that's all right. While we're here, we're also going to find our horizontal asymptotes. Flip to the front page if you need to. What do you remember about horizontal asymptotes? Yeah, where's your highest power at? So what's my highest power on top? 2x. What's the highest power on bottom? 3x. So what do you notice about these powers? When the powers are the same, what do we use?
The leading coefficient.
The leading coefficient. So we use the numbers that are out front there. So we're going to use y equals what? 2 over 3. Okay? So those are my asymptotes. And in fact, we can go ahead and put in those asymptotes if you want. X equals 4/3. Well, 4/3, that's in my brain. I don't know what your brain says. My brain says 4/3 is 1 1/3. So it's a little bit above 1, yes?
Yep.
Okay, so x equals 4/3. I'm going to, on the x-axis, go to 4/3. I'm going to go a little bit past 1. And I'm going to put in my vertical asymptote. It's not exact because, hello, it's hard to do 1 1/3, isn't it? But it's somewhere between the 1 and 2 line. Good enough?
Yep.
Okay. A horizontal asymptote of 2/3. So now I'm going to cross through the y-axis at 2/3, which means what?
A little under 1.
Yeah, just a little bit under 1. So they're almost like the x and y axis, just not quite. Now, I mean, we have a 50-50 shot. Either my graphs are going to go this way, or they're going to go, my hands can't do it that way. Not at this angle, but they're either, this way or this way, right? We have to figure out which. So the other thing we're going to definitely be asked to find are intercepts. So I'm going to kind of call this step 2. And I think I usually start with the x-intercept. I do. Okay. So x-intercepts are where my graph crosses the x-axis, right? On the x-axis, what is the y value always? 0. So we're looking, and I'm going to give you an easier way. For an x-intercept, we're looking for when y equals 0. Okay, that's technically what you're doing. Now, y in this equation is f of x. Okay? So when does y or f of x equal 0? Well, tell me, when does a fraction equal 0?
Divided by 0.
Not divided by 0. Well, when it's 0 divided by something. Okay, when it's 0 divided by something. So basically when your numerator. So the shortcut in order to find your x-intercept is to set your numerator equal to 0. What's my numerator?
2.
2x plus 1?
Oh, yeah.
So if we set 2x plus 1 equal to 0, subtract 1. So 2x equals negative 1. Divide by 2 and more specifically negative 1/2. Maybe she said the negative, I missed it, but okay. So we have an x-intercept at negative 1/2. Now, we said that this was going to be our x-intercept. If you prefer, I don't know, do you prefer an ordered pair? An x-intercept of negative 1/2 is negative 1/2 comma 0, if you prefer to express it like that. I also want to find a y-intercept. Now, a y-intercept is when my graph crosses the y-axis. What is true of all x values when we cross the y-axis? X is 0, yes? So to find my y-intercept, we're going to put x 0 in for x. So I'm just going to say let x equals 0. So go up to your original equation and put 0 in for all of those x's. So y equals 2 times 0 plus 1 divided by 3 times 0 minus 4. What'd you say? 1 divided by negative 4, right? Because 2 times 0 is 0, plus 1 is 1. 3 times 0 is 0 minus 4, negative 4. So I would say that my y-intercept is negative 1/4. Now, if you have to do that as an ordered pair, what comes first? X, which is 0, comma negative 1/4. Okay. Let's put those 2 points on the graph real quick. X-intercept of negative 1/2. That means on the x-axis, what do? You go half a box left of the origin. I know, it's not big, but these aren't the best fractions in this problem. There's a lot of fractions, unfortunately, sorry. A y-intercept of negative 1/4. On the y-axis, what's that saying you do? You go down a quarter box, a quarter of a box. Those 2 points are kind of close to each other, aren't they? That's all right. Now, I would argue, since we know what this graph looks like, I know enough to sketch this graph. Where does one of my curves have to be?
The bottom left one.
The bottom left, yes. It has to stay below this horizontal asymptote. It has to stay to the left of this. So it's going to curve right along there. Okay? I would argue we know enough to do that. Now, based on what I've said for this unit, where's the other one have to be then?
The top right.
It's going to be in the top right area. Okay? Now, what I would say to confirm this is that we maybe check a couple other quick points. Okay? So my step 3, and kind of depends. You may or may not always need step 3. Fair enough? It kind of depends on the situation. So I'm going to suggest we maybe try a couple other points. Just if you're feeling a little unsure, because I know some of you guys gave me that crazy look like, we know enough to graph this? Are you crazy? Well, maybe, but we do. We know enough to graph it because I told you what the shape of the graph is going to look like. Okay, now, so we're confident that over here on the left is going to be down below, yes?
Yeah.
Let's pick a couple of points over on the right and see what happens. Well, so like here, let's go, right now we're to the left of this vertical asymptote. What is my vertical asymptote? It is 4/3, yes?
Yeah.
Let's pick at least one point to the right of 4/3. What number is to the right of 4/3?
5/3.
Okay, I was going to go with whole numbers. I wasn't going to go fractions.
4,
2.
8, 1, 4.
Well, okay, wait. 4/3, what is 4/3, guys? I talked about this earlier.
1/3.
It's 1 1/3, yes?
So 2.
So I need something bigger than 1 1/3. Could we use 2? And I guess what I usually say is pick something on either side of the asymptote. So we could pick 2 to the right of it, and we could pick,
2 to the left of it. The negative 2.
no, not where I was going with that.
Oh.
I guess what I was looking at, sorry, is that if my vertical asymptote is 1 1/3, yes? Are you with me on that?
Yeah.
The whole number to the left of that is 1. The whole number to the right of that is 2. And this will confirm where points are. Now, I would argue the 1, it's going to put me down here somewhere. Okay? But it might be helpful. The 2 should put me up here. And you can do more points. I heard things like 3, 4, 5, 6, 7, 8. Could you do those points? Yes, but how many do we really want to take time to do?
Not many.
Exactly, not that many. Okay, so let's put in 1 up here. If you put in 1, 2 times 1 plus 1 over 3 times 1 minus 4. On top, 2 times 1 is 2, plus 1 is 3. On bottom, 3 times 1 is 3, minus 4 is negative 1. What's 3 divided by negative 1? Negative 3. Okay, let's put in 2 also. Going to the original problem, so 2 times 2 plus 1 over 3 times 2 minus 4. Is everyone with me on where I'm plugging these in? Original problem, yes? 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, minus 4 is 2. I personally like 5 halves. I'm getting this since we're struggling. What is 5 halves?
2.5.
2.5? Would that be, I could say 5 halves here, but if you don't like 5 halves, could you say 2.5? Does your brain work better that way? Okay. Now let's look at where these points are and see if they confirm what we were already thinking. 1, negative 3. From the origin is right 1, down 3. It's right there next to the asymptote, yes? But is it continuing with the shape I was suggesting we would have down there?
Yeah.
Yeah? Now, what about 2? It's 2, so 2 right, and then up 2.5. Does that put my other curve in the upper right like we were expecting it?
Yeah.
Yeah. Okay. If you want more points, you can put more points in there. I'm not going to require it. Okay. I have my confirmation of where my pieces are. On the left, I can connect. Now, as I connect, I'm going to be running underneath that horizontal axis right there, and I'm going to be running to the left of that vertical axis. Does that make sense? I connected the points I had, right? On the right, I only have the 1 dot. Can you basically make this same shape? We're going to be running along this here, and then we're going to turn down here and run right along there. Okay?
We gotta do that the other points.
You could have gotten away without it. The more we get into this, you could possibly get away without doing the other points, depending on the scenario. Okay? Questions I should answer here? No? Okay. Shall we try 2? See if it makes a little bit more sense? We'll still have some fractions, but not as many. Okay? Okay. So, reset. I just realized I kind of wrote into my next problem. That's not great. Whoops. Okay. What did I start with last time? My asymptotes. What are you thinking for vertical asymptotes here?
X plus 8 equals 0.
Denominator equal to 0. So x plus 8 equals 0, which means I'm going to have a vertical asymptote at x equals negative 8. Ooh, that's going to be way over there, isn't it? You can go ahead and put it in if you want. It's going to cross the x-axis at negative 8. So it just means my graph is going to be way shifted over here. That's all right. We'll make it happen. And remember, vertical asymptotes, what are we doing? Denominator equal to 0. Okay. What are you thinking for horizontal asymptote this time? Look at your powers. Highest power on top is 4x to the first. Highest power on bottom, x to the first. When the powers match, use the numbers out front. What are my numbers out front? 4 over 1. And 4 over 1 is 4. If you want to start off saying 4 over 1, you can, but it's going to be 4. What's this mean? On the y-axis, we're going to cross through the y-axis at 4. So you're going to have a horizontal asymptote over there. Okay. What do we do next?
The x-intercept stuff.
Yeah. X and Y intercepts. X-intercepts happen. Yeah. I like to say when y equals 0, but then that means you're saying your numerator equal to 0. Okay? So numerator equal to 0. What's my numerator? 4x minus 3 equals 0. So add 3. 4x equals 3. Divide by 4, and x is 3/4. If you want to think about this as an ordered pair, it's 3/4, comma 0. Can you go ahead and put that on your graph? X-intercept of 3/4. What are we doing? Right 3/4. So it's just between 0 and 1. What about when do y-intercepts happen?
Let x be 0.
Okay, y-intercepts happen when x is 0. So go to your original problem. Y equals 4 times 0 minus 3 over 0 plus 8. 4 times 0 is 0 minus 3 is negative 3. 0 plus 8 is 8. So we have negative 3/8. And again, if you want the ordered pair, it's 0, comma, negative 3/8. I don't know if the ordered pair is better or not for you guys, so. What's this mean on the graph? On the y-axis, you go down 3/8 of a box? Less than 1, yes?
Whatever happened to whole numbers?
I don't know. I didn't do a good job on picking whole number examples in this lesson. How's that? AKA, there probably weren't many whole number examples. Okay? Now, with this in mind, okay, it's a weird one. But again, these 2 points mean we're going to have half of our graph down here in this bottom right, yes? Where's the other half of the graph going to be? In the top left over there that's not set up very well. Now, your other points should confirm that. And I know, part of me wants to skip the other points. If you get comfortable and you skip the other points, that's fine. But here's what I'm going to suggest for other points. Okay? Pick numbers on either side of your vertical asymptote. What is my vertical asymptote?
4 or negative 8.
Negative 8. Give me a number on either side of negative 8. Negative 7 and
6. Oh, 9.
other way, negative 9. Okay? Now, plug them into original, yes? 4 times negative 7 minus 3 over negative 7 plus 8. 4 times negative 7 is negative 28 minus 3, negative 31. Negative 7 plus 8 is 1. Negative 31 divided by 1 is negative 31. Okay. Let's do negative 9. I know, we can't really graph that, but it tells us if we're in the right area. Okay? Let's do the same thing with negative 9 real quick. 4 times negative 9 minus 3 over negative 9 plus 8. 4 times negative 9 is negative 36. Minus 3 is negative 39. Divided by negative 9 plus 8, negative 1. What's a negative 39 divided by a negative 1?
Positive.
A positive 39. Now, the fact that one of these is negative and one of these is positive is a good thing. Okay? So think with me. Negative 7, negative 31. So negative 7 is right here, yes? Negative 31 is, I don't know, down here somewhere. Does that complete, does that go with the fact that we already have these 2 points that puts me in this fourth of the graph? Okay? Negative 7, that was that one. Negative 9, 39. So now negative 9 is going to be where? We're going to go past the vertical asymptote, up 39? Well, where did we say we thought the other piece was? in that little sliver over there, yes? So, with all this in mind, okay guys, I'm just going for general, right? We know that this graph is going to do something like that. Okay, it just doesn't go as close over there. Okay? Now, this other piece, I can't really draw in very well, can I? But what I do know is it's going to go up along here, and it's going to go out over there. Okay? That's not the best drawing because there's only so much I can do with this graph the way it's scooted. But again, what I'm trying to get you to see, do you see the points supporting this?
Yeah.
And again, based off of what did I tell you, what's the shape of this graph, I expect you to know. It's those two curves going out, right? Now, if we don't know it's the two curves going out, this is really difficult. But if you assume this is the two curves going out, it goes together. Fair enough? Okay. I only have one fraction on C. There's only one fraction on D also. Let's look at it. Okay. C. We've been starting with what? Okay. Asymptotes, specifically the vertical variety. To do the vertical variety, I'm hearing all good stuff. You're telling me denominator equal to 0, which in this case, x plus 3 equals 0. So where's my vertical asymptote? X equals negative 3. You want to draw that in now? X asymptote negative 3 means we go where? 3 left on the x-axis and draw your vertical asymptote. And notice, you guys realize vertical asymptotes are just shown as dotted lines, right?
Yeah.
Okay. What about horizontal?
Weird. It's like no power. Or like there's no X.
There is an X.
It's on bottom.
But yeah, but it's not on top.
Okay. So on top, my biggest power
Zero.
is 0 because it's negative 1. Okay. In the denominator, what's my biggest power?
1.
X to first. So where is the bigger power here?
5.
Okay. So I'll even write myself a note here. Larger power on bottom. Okay, we haven't done this one today. It's on the front of your paper if you need to go back. Larger power on bottom means y equals 0. That's the rule from the front page, yes? So y equals 0. That is the same as the x-axis, yes? Okay. After we have our asymptotes drawn in, what have we been doing? X and Y intercepts. What are your thoughts on x-intercepts here? Okay. Well, what have we been doing? We've been setting the numerator equal to 0. What's my numerator?
Oh, it's gonna be
We're going to set negative 1 equal to 0. Where's my variable? There isn't one. Does negative 1 equal 0?
No.
No. So what this is saying is that there is no x-intercept.
It's like a hole or something.
No, it's just saying my graph will never touch the x-axis. It'll never cross the x-axis, which is reasonable because what is my x-axis acting as? A horizontal asymptote, yes? So if you think about it, it's supposed to run alongside that horizontal asymptote. It's not going to touch it. So no x-intercept makes sense. Now, we've got to cross the y-axis somewhere. So let's find our y-intercept. X-intercepts happen when y equals 0. Y-intercepts happen when x equals 0. So y equals -1 over 0 plus 3. The only fraction in this problem. -1 over 0 plus 3 is going to become what? -1/3. If you want that word pair, it's 0, comma, -1/3. Okay. 0, -1/3 is what? From the origin, left to right, 0 and down 1/3 of a box. Okay. Based on that little information, you could argue that you know which two places to put your graph. For confirmation, could you look at an extra set of points?
Yeah.
Okay. And what I will say, the habit I'm trying to get you in is pick points just on either side of my vertical asymptote. What's my vertical asymptote? -3. Give me a number on either side of -3. -2 and what was it? -4. So -1 over -2 plus 3. -1 over 1, which is -1. And then put in -4. -1 over -4 plus 3. -1 over -1, which is +1. Okay. Does this confirm what you were thinking, maybe? -2, -1 is going 2 left, down 1. That kind of goes with my y-intercept. It puts me in that bottom right corner, doesn't it? -4, 1 takes me 4 left, 1 up. I just went past my asymptote and up, and now I'm in that other quadrant. Okay. I know enough to put that in there. Okay, so you can attempt to connect your points here, which in this case, again, if you guys caught on, I'm just basically running alongside the asymptotes, aren't I? That's all I'm doing. I'm trying to hit those points and I'm running alongside the asymptote. Here I only have 1 point. Just know, whoops, we're going to run alongside these asymptotes. And do me a favor, do realize it's going to be curved here in the corner, yes? It's not going to be a pointy corner, it's going to be a curved corner. Okay, getting the hang of it. Got one more here. How much can you lead me through? There's a lot of steps, I know. That's why you have them in front of you. And not that I want you in this habit, because you know you don't have this on a quiz or a test. Could Desmos maybe help you to check? I would always make that my very, very, very last step. Okay? Okay. Did you guys start D? Are you ahead of me? What are you doing? Vertical asymptotes. Vertical asymptote, what are you getting? It's the, it's that x minus 1 equal to 0, because it's our denominator equal to 0. X equals 1. Do you like if I go ahead and put them in as we go? Do we care? I don't know. Some of you like it. So x equals 1. So on my x-axis, I need to go 1 over. I'm going to cross through x at 1. So I'm going to have a vertical asymptote right there. What about horizontal asymptote?
3x over x.
Okay, biggest powers. 3x to the first, x to the first. So we're using 3 over 1, which is 3. So horizontal asymptote of 3 means you go on the y-axis, you go up to 3 and draw a horizontal line. Okay. After asymptotes, I've been doing x-intercepts. X-intercepts.
3 times 0 plus 2.
Okay, yeah. Officially, it's when y equals 0, so that's when my numerator equals 0. So 3x plus 2 equals 0. Subtract 2. 3x equals negative 2. X is negative 2/3. It's the only fraction in this one. So where's an x-intercept of negative 2/3? On the x-axis, you go...
Right. Or right 2/3. Left.
I'm going to go left 2/3 of the origin.
I knew what I was doing. I just couldn't say it.
Okay. And that's of the origin, yes. And then for the y-intercept, this is going to be when x equals 0, right? I guess I usually write let x equal 0. So y equals 3 times 0 plus 2 over 0 minus 1. Three times 0 is 0, plus 2 is 2, 0 minus 1 is negative 1. What's 2 divided by negative 1? Negative 2. Y-intercept of negative 2 on the y-axis, go down 2. Okay. I have confidence I could draw this. And again, I'm not worried about very specific graphs, am I? We're getting the general shape. If you try some other points, what other points could we try? I keep suggesting you go either side of your vertical asymptote. What numbers are on either side of my vertical asymptote?
0 and 2.
0 and 2. Now, and I agree. Technically, did we already do 0?
Yeah.
We did 0 and got what?
Negative 2.
Negative 2. So that one's done. We know it's going to be down there. Where should 2 put us?
That's top right.
2 should put us up here somewhere. Let's check it out real quick. 3 times 2 plus 2 over 2 minus 1. 3 times 2 is 6. Plus 2 is 8. 2 minus 1 is 1. 8 divided by 1 is 8. Is this where you expected it to go? If I go right 2 and up 8. Does that put me in that same quadrant? Okay. Puts me in the quadrant I expected to be in. Connect your dots. Notice, as I connect my dots, I'm making sure that my graph runs along my 2 asymptotes. Okay? Now, good news about Savas, you know you're going to be doing some multiple choice stuff, right? But you are going to have to answer some questions about asymptotes, intercepts. I don't think they ask extra points, okay? You're sometimes just going to be picking the graph. Just kind of depends on what you're looking at here, okay? And remember to watch out for holes that we talked about yesterday, too. I want to say it was 12 questions, maybe? Yeah.